Good morning. Um, yeah, these pages are wrong. I'm told it's 81 and 82 for graphing cube roots. You're welcome. So get your table of contents taken care of. Now what we're going to do today, graphing cube roots is not going to take very long. I'm going to give you some time in class to work on that homework. Hopefully you'll get it done, and then we're going to start the next lesson, all right? You won't have homework on it, but we're at least going to get it started. Can we put it in the table of contents now? Give me a second. I'll tell you what, why don't we just go ahead and finish the table of contents for this unit. So after graphing cube roots is solving radical equations. And that will be just one page. So I guess, is that 83 then? And then application. And that will be your one single page. So that's what we're looking at right there to finish this unit. And I did get your quizzes graded, so I will we'll go over those today as well. There were many that were good. There were some that weren't good. All right, you ready? Get that recording. Okay. This is the pink sheet that you have in your possession right now. This one right here. Now, if you remember, on Friday we graphed square roots. Today we're going to graph cube roots. We're not going to graph any roots past that, but square roots and cube roots are the most common ones. Now, you'll see right here, and you can't see it very well on my board, but you can see it on yours. That's x cubed. Do you guys know what x cubed looks like? It is x times x times x. And Bethany's motioning with her hands what the end behavior looks like. And what she was showing, correct me if I'm wrong, that it goes down this way and up this way. Is that what you were saying? Yeah, that's right. That's right. So let's, Judd said that x cubed means x times x times x. So what we're going to do is we're going to just plot some points, okay? Remember, x times x times x. So we're going to do, it's all right, I just wondered what it was. I want you to use those x values. And let's raise those to the third power and see what the y values are. What is negative 2 to the third power? Negative 8. Because remember, a negative times a negative times a negative is a negative. So that's negative 8. What's this one? Negative 1, 0, 1, 8. Go ahead and plot those 5 points. Now, if you remember on Friday, we talked about x squared. And we talked about that word inverses. Do you remember what inverses do to each other? Anybody remember what inverses do to each other? Well, that's not the best word. Cancel is not the best word. Flip-flop, what do you mean?
Like the y goes first, the x is, yeah.
Okay. I'm not sure I completely understand that, but I know where you're going. Do you remember that the x's and y's swapped? You remember that? Do you remember they undo each other? undo each other? Like, if I give you a number and I say add 6 to it, how do you undo adding 6? You subtract 6. Adding 6 and subtracting 6 are inverses. If I take some number and I multiply it by 2, how do I undo multiplying by 2? I divide by 2. Multiplying by 2 and dividing by 2 are inverses. They undo each other. So the question is, what undoes x cubed? The cube root. What undoes x squared is the square root. What undoes x cubed is a cube root. And you've worked with cube roots, not graphing, but you've worked with them. And that looks like this. Remember, the address of the house is cube root. So write that right up here. Now, Bethany said, oh, the x and the y's flip-flop. So what are the points that are going to be on the cube root of x? Negative 8, negative 2. That's easy. Good. Plot those 5 points on this graph. Okay. Let's talk about the domain and range of each of those functions. Look at x cubed. So look at the one on the left. Domain. And by the way, you guys are getting so much better at domain. I will say on one of the homeworks, and it was Danny's, I loved, here's what she did on some of the graphing when she had to do domain and range. She did this. She drew this and wrote domain. And then she drew a vertical one somewhere, and she wrote range. And that really, I think that maybe helped you, because every time she did that, she nailed it. So, no, but it seems to have healed itself. I don't know. You're exactly right. Knock on the fake wood. All right, so what's the domain of this function, x cubed? Now, I want you to look. Do you notice that it goes down really fast and it goes up really fast? Does it move to the left and the right? Gradually, but does it move to the left and the right? Could I do negative 3 cubed and negative 4 cubed and negative 5 cubed? Sure could. So what's the domain? Negative infinity to infinity. Good. What's the range? Also negative infinity to infinity. If you're going vertically up and down, negative infinity to infinity.
So could you just tell it because the graphs keep
Cube root of x. What's the domain? This way. Negative infinity to infinity. And the same on the bottom. Yep. Somebody's enjoying some chips back there. Now, I want you to notice something, and it's not so obvious on this one. You remember how Bethany said the x and y's flip-flop? Remember that? Well, if the x and y's flip-flop, that means the domain and range flip-flop. Because domain is, what's domain? X, and range is y. So if the x and y's flip-flop, that means the domain and range flip-flop. So if you know what the domain of this one is, then you know what the range of this one is. And vice versa. Those just flip-flop. Okay? All right, you've got a little bit of stuff toward the bottom of that paper. Identify the transformations on the parent function. Look at that first one. Okay, a lot of stuff going on. Here's what I want you to do. I want you to talk to the person next to you, or if you're solo, turn around and talk to the two people behind you. And I want you to decide what are the transformations on part A and part B. Go. Okay, I'm going to call on people because you've had time to work together. Ready? What's that 2 mean?
Vertical stretch by a factor of 2.
I was going to, it's all right. The 2 is a vertical stretch by a factor of 2. What's the, let me call on some people. Okay. Left 2 and down 1. Okay, good. Have mercy. All right. What's that negative do here in the reflect over the y-axis? What's that 2 do then? Good. That's a horizontal shrink by a factor of 1/2. And I don't want to just put by 1/2, put by a factor of 1/2. And then I heard up 2. Good. Good. Up 2. All right. Look at example 2. We're going to write a new function. Here's what we're told. We're told the parent function is cube root of x. Now take a look at the things that are happening to it. Horizontally translated left 5. Reflected over the x-axis and up 4. And then you're going to do the second one. Horizontally stretched by a factor of 2. Reflected over the y-axis and down 3. All right, go at it. Let's talk about this first function. We're going to, probably don't want to write with a highlighter. G of x equals, all right, Danny, what kind of equation did you get? Tori, do you agree?
Yes. Yes.
Gabe, do you agree? Good, well done. Okay, let's look at B. Manny, did you get one for B? No? I'll come back to you. It's, well, what'd you get? Let's talk about it. What'd you get? Read it to me, sweetie. Yeah, you do.
G of x equals
Cube root. Where's the plus 3 go? Plus 3?
Out of the yeah.
Okay. Horizontal. So you're saying this should be a half? Is this, should this be -2 or -1/2? Anybody else think? You have an idea? -1/2. Yeah. Okay, is everything else good? Okay. What do you think? Down 3, so -3 here? Good. That's your answer right here. Okay, now we're going to take the graph paper that I gave you. Didn't I give you a piece of graph paper? Fold it Z. Okay, I'm going to go through the first one with you. Identify the transformations from the parent function and then graph the radical function. Can you see number 1? 3 times the cube root of x plus 4 Now I'm going to give you about 30 seconds to think about what the transformations are. By the way, calculator 11 is missing and calculator 21 is missing. Yeah. Do you have calculator 21? What's this 3 stand for? Vertical stretch by a factor of 3. Why do you think we say factor? Because it's multiplying. Good, because it's multiplying. And then left 4. Good. Left 4. Now, you have your pink sheet where you see the parent graph. We're going to take each of those points and we're going to do a vertical stretch by a factor of 3 and we're going to go left 4. Now what I'm going to do is I'm going to plot those points 0, 0, 1, 1, 8, 2. Then I'm going to go over here. I don't know, can you guys see that at all? I don't want it to be real, because it's the parent graph that I'm going to move around. Okay? Let's start with 0, 0. If I do a vertical stretch by a factor of 3, where does it go? Stays the same. Because why? Because 0 times 0 is 0. Good. 0 times 3 is 0. Yeah. And then what do we do to it? Left 4. 1, 2, 3, 4. So that's that point. Now let's take the point 1, 1. Vertical stretch by a factor of 3. What gets multiplied by 3? The y value. So it's going to be 1, 3. And then 1, 2, 3, 4. Then left 4. 8, 2. Vertical stretch by a factor of 3. 8, 2. What happens? The y is multiplied by 3. So what's that point going to become? 8, 6. And then 4 left. Is it making sense? Andrew, you all right? You're scrunching up your nose a little bit, just checking. Okay. Look at this point, -1, -1. Where's that go? Vertical stretch by a factor of 3. What happens? So it's going to, what do you do with this? What do you do with the y value? Times it by 3. So where's it go? -1, -3, and then?
Left 4.
Right there. -8, -2. Bless you. -8, -2. How do you vertical stretch by a factor of 3? What do you do? -8, -6. And then? Left 4. And I may be off. We're just going to have to go over there. And there's your graph. Can you see that that thing is vertically stretched? Can you see that this thing was shifted to the left? Let's talk domain and range. For what? Negative infinity to positive infinity for what? For the domain? What about the range? Same. Ladies and gentlemen, don't you ever get domain and range wrong on a cube root, because they're negative infinity to infinity, both of them all the time. That's terrible. Let's try that again. Negative infinity to infinity. You got a feeling. What you got a feeling about? I think we'll do this one because it's got a negative inside the cube root. What's the negative inside the cube root do? Reflect over the y-axis. What's the plus 2 do? So I got to reflect over the y-axis, and I got an up 2. I'm going to go in there. I don't know if it helps you or not to plot the parent graph, but it helps me. Okay, you ready? Let's take the point 0, 0. Let's reflect 0, 0 over the y-axis. Where does it go? It stays there, and then up 2. The point 1, 1. Reflect over the y-axis. Not negative. No, the x value is not negative. Oh, hang on a minute. Reflect over the y-axis. Yeah, I went the wrong way. Reflect over the y-axis and up 2. Negative 8, 2. Reflect over the y-axis and up 2. This one, reflect over the y-axis and up 2. And here, reflect over the y-axis and up 2. Now, I know I went through that kind of quickly, but do you see the reflect over the y-axis and the up 2? You see it? We've got 3 more graphs, but we're just going to pick one. We can do number 3, which says, yeah, I don't think we're going to do that one. What does this one say to do? Reflect over x, down 1. That's easy.
Number 5.
Look at number 4. I can't tell if that's a 1 or a 4. That's a minus 1? Yeah, can't tell. Yeah, that's a minus 1. And right 1 up 2. What about number 5? You think we'll do number 5? Yeah, let's do that one. So that'll be our last one to do, okay? So can you read it? Negative 3 times the cube root of x plus 2 minus 3. Write down your transformations. All right, name one transformation. Jordan, name one. One transformation. Good. Not in yellow. Reflect over x-axis. Andrew, give me another one. Good. Vertical stretch by a factor of 3. Tori, give me another one. Down 3. And y'all said there were 4, so that means one more. Left 2. Good. All right. Give it a whirl. I want you to plot it, okay? Help each other. Now, those of you who are watching this, I'm just going to do it by myself, okay? So I'm going to start with the point 0, 0, then I'm going to go to the point 1, 1, then 8, 2, then I'll go to the negative side. But I'm going to be quiet so they can work without me interrupting them. Reflect over the x-axis. Vertical stretch by a factor of 3, down by 3. Reflect over the x-axis. Vertical stretch by a factor of 3. Let's see. Uh-oh, that's not right. There it is. I think I screwed that one up too. -8, -2. -8, 2. -8, 6. -8, 3. Yeah, that's right. There. You may have graphed it faster than I did. Those are the 5 new points that I got. Tell me if there's anything I messed up. I didn't record that. That's all we're going to graph. I'm going to give the assignment, and then if you have questions, we can just talk one-on-one or small group.